Okay, so now we're going to talk about section 10-5. 10-5 is about intersecting secants. Now we talked about what a secant is earlier in this section. And we're going to talk about intersecting secants within, so when they intersect inside a circle and outside a circle. Now I'm really sorry I don't have a compass at home. I did not bring a compass home, but if we have a circle here, and remember a secant is a line that passes through a circle. So I'm going to draw a secant here, and I have circle, we'll call it circle T, and we have secant AB, okay? And then I have a second secant that intersects that secant inside my circle. Now notice, they are not intersecting on my circle. The point of intersection is within the circle. Now that point of intersection is also not the center of the circle, okay? So this is intersecting secants within a circle. So secants within a circle, okay? Now, here's what's interesting about this. There's a formula, and it's a direct formula. Now, on this next page, I'll derive it, so you can stop if you just want the formula, but I'll derive it for you. But what the formula is, and we'll call this one CD, the formula is X is actually the average of the two arcs that are contained. So X, notice where X is. So X is here, and it's linear, or it's not linear, but it's a vertical angle. So this is also the X value. So each one of those is the number, the value of X. So X is the average. So the measurement of AC plus BD divided by 2. Okay? So it's the average of these two contained arcs. Okay? Now let's talk about two secants that intersect outside the circle. Circle T again. And now we're going to have point C here, point D, point A, point B. Okay? Now here is our angle X. And notice X is the angle made by two secants intersecting outside the circle, and X is the angle contained. So now our formula for this, so secants intersecting outside. Okay. Now, the way we do this one is we take, there's a big arc, as you can see, and a little arc. And this is always true. There's always going to be a big arc and a little arc. So the way we calculate this one, so X is equal to the measurement of the big arc minus the measurement of the little arc over 2. So in this case, our big arc is arc BD, and our little arc is arc CA, or AC. Okay. All right. Now, if you're, there we go. So we have our little arc and our big arc. Measurement of the big arc minus the measurement of the little arc divided by 2 is equal to our X value. Straight formula. Now I'm going to show you the reason it works. So if you just need the formula and you want to finish the problems, go ahead and work on those. And I think we're doing 16 through 29 all on that page. So on page 457, so the homework for this one would be page 457 at the end of 10-5, the PDF will be added, 16 through 29 all. All right, the reason this works with the intersecting of two secants inside a circle so we have secant AB, secant CD. And we're looking for our x value here. Now, the reason this works is that if we connect D to B, we create inscribed angle ABD. So we have the measurement of angle ABD. Now we also create angle CDB. Now, based on our inscribed angle measurements, we know that the measurement of ABD is going to be half of arc AD. And we know that the measurement of CDB is going to be half of CB. Now, so this is half of what? And this one is measurement of AD divided by 2. Now, the exterior angle of a triangle theorem. So remember, this is our triangle, and x is an exterior angle of a triangle. The exterior angle of a triangle theorem states that the measurement of angle 4 is equal to the measurement of angle 1 plus the measurement of angle 2. So there are two remote interior angles. So x would be angle 4, and measurement angle 1 would be D. The measurement of angle 2 would be this one, measurement of AD over 2. And we add the numerators and the denominators stay the same, so x equals measurement of CB plus the measurement of AD all over 2. And that's where our formula comes from. Now, likewise, on a triangle where we have two secants that intersect outside the circle, okay, well, if we talk about this, is x. So x is that measurement. It's the angle that contains the little arc and the big arc. And remember, the measurement of x is equal to the measurement of big minus measurement of little arcs all over 2. So here's how this one works. If we connect C to B, and you could do AD also, but if you connect the diagonal one, what we do is we create an inscribed angle from ABC and an inscribed angle BCD. Now we know this one is half of our big arc. So this is half of measurement of BD. And we know this one is half of our little one, measurement of AC over 2. Now, x is one of the angles, one of the remote interior angles of this situation. So we have, in the same case, measurement of angle 4 is equal to the measurement of angle 1 plus measurement of angle 2. Okay, two remote interior angles. Well, one of those remote interior angles is x, and the other one is the measurement of angle AC, or our little angle. The measurement angle 4 is our exterior angle, which is our measurement angle BD over, measurement arc BD over 2, and then we solve for x. So x equals measurement of BD over 2 minus the measurement of AC over 2. Therefore, X equals measurement of BD minus measurement of AC, those two arcs, over 2. And that's how that works.